Hello everyone. Want to go over right now about fractional exponents. Again, more about this is about radicals, but this is when you have radicals that the exponents aren't whole numbers, they're fractions. Now, a lot of times when we deal with rational exponents, you tend to think of first deal with roots a lot. So you get one of my favorite examples, square root of 16. Now, we also know that when there's not a number out in front of the, here we go. When there's not a number out in front of here, you always assume that there's a 2. Or you could deal with maybe like the cube root of 8. Now, when you're used to dealing with powers, let's say squares, you're used to something that looks like this. Without the unusual square root symbol going on. Well, you can actually write the square root using that if you think about this as a fractional exponent. So you can almost rewrite that as 16 to the 1/2 power. So all square root is a number to the 1/2 power. Same thing with 8 here. Now you can see that as 8 to the 1/3 power. Now the way this was explained to me in terms of kind of going back and forth between the two, you can almost think about this as a kickstand, where you start off this way and you kick the bottom number out. So that 3 there would be kicked out in front of your root symbol. The number's still the same, and if there's a number up here, you can put it here, but we assume anything to the first power is just itself. Now, this is good for, let's say you have very simple. Again, if you see the 4th root of 64, well, you can say that, you can usually rewrite that as 64 to the 1/4 power. Going that way. Now, the other thing you can think about this as is if you can have a power that's not a 1 over something. So if you have, let's say, 8 to the 2/3 power. Now, most of the time, when I see a problem like this, well, you can rewrite it. You notice how that 2 stays there as a square. The 3rd part gets kicked out as a cubed. Now, one nice thing about when you deal with powers like this is you can go either way first. So you can either square that first and take the cube root, or cube root it first and then go for the squaring, the cubing, the fourthing, the fifthing, and such. I normally like to do the root first. It's easier to calculate because when you have that, let's say in this case you want to rewrite that as a cube root of 8 and then square it later. You can figure out the cube root of 8 is 2 because 2 times 2 times 2 is 8. So that gives you 2 squared. And that's very easy to figure out. 2 squared is just being 4. If you try to do it the other way, it still can be done. So if you want to do it the other way, you could do the cube root of 64. Now, that's a little harder in terms of a student who's starting off, who's not familiar with what all the cube roots are in terms of having to look it up on a table and understand what's going on. So in this case, you could say, well, I know the cube root of 64 is in fact 4. So you notice in this case, we do have the same answer. Right? We have this and this being the same answer. Even though they're the same answer, I really prefer this method for comprehension, just because when you do it, it's a little bit easier to do that cube root and bring it down and then raise it to a power. Also, when you do something that's a root other than a 2, let's say, so you get a cube root, a 4th root, it really kind of limits what numbers work out to be whole numbers. And a lot of times, not necessarily in the real world, but in book problems, they do select them so you do get that whole number out. So you can have something that looks really, really nasty. You have 125 to the 2/5 power. Well, obviously, if you square 125, you're getting an exceptionally long number over 10,000. You have to find the fifth root of that. That can get messy. But if you do the fifth root first, so if you do the fifth root of 125 squared, that can make it a little bit easier. And actually, this is where, when you're trying to make problems, and this is a good hint, if you try to make problems up in your head, you can sometimes get into problem. This should be really the 2/3 is what I was going for. Who caught me on that one? And did I do it on purpose? So, again, still, you're talking about over 10,000, and the cube root of something over 10,000, a very large number. One you would have to go for a calculator for, which, yes, calculators are important and necessary, but they're not 100% necessary all the time. They're a nice thing to have. However, most of algebra was, most of everything built in the world outside the last, I don't know, 20, 30, maybe even 40 years on some stuff was done without computers, let alone calculators. The space program up to the Apollo and a little bit past the Apollo moon landing, assuming you think it happened, was done on paper, slide rules, basic. Pretty much a lot of the roads built in the U.S., if they're older roads, were built without computers. Pyramids, without computers. Assuming you don't think aliens made them. So, this is why I think it's good to, if you can do numbers like this, because then you get your cube root of 125, which is 5 squared, which gives you 25. Again, now how do you know the cube root of 125 is 5? You either do a lot of problems and you see that happen a lot, so you recognize it as memory, or you can look up and say, I'm doing radicals or I'm doing roots, so therefore I have to know what the square roots I'm pretty good on, cube roots, not so good. Fourth roots having some issues, so you're either going to write them down next to you, so you're familiar with them, or you know where to reference them. And that's one of the biggest things in terms of when I was in school and learning the different math, even engineering math, is that a lot of my professors said, it's good to know this in your head. However, you're going to have reference books. Now, this is a long time ago, pre-internet. Or I should say easy high-speed internet at home or your mobile device or anything else. So you had big books, big, thick books. And those big, thick books had a lot of the formulas you needed, so you didn't have to memorize them. It was more of you had to know how to use them correctly. Now, one last example here, and this is one that gets a lot of people in trouble because we've seen that when you have 2 to the negative 4. So you have that negative in the exponent. Now, again, you think, oh, negative in the exponent, that means my number's negative. No, it means that when you have a negative in the exponent, now remember, all numbers are over 1 if they're not already a fraction. So, since that's a negative up there, you just change that to, move that from here down to the denominator. And since when you move it, there's nothing left, keep that 1 up there. And 2 to the 4th, well, 2 times 2 is 4, times 4 is 8, times 2 is 8, is 1/16. So you can still have the same thing. Let's say you have a problem that looks like this. So you got 1/8 to negative 1/3. Now, notice you got tons of fractions here. When I deal with something with a negative exponent, I want to make that negative exponent into a positive before I do anything else with it. And the way you make that negative a positive in terms of the exponent is you flip the fraction. So that 1/8 now gets flipped 8 over 1 to the 1/3 power. Now, the other thing is, notice that 8 over 1, we know we can just rewrite as 8 to the 1/3. And this is just the cube root of 8. So we need to think of a number that's multiplied 3 times to give us 8. Well, obviously 3 times 3 is 9. We're already too big. 2 times 2 is 4 times 2 is 8. So in this case, the answer is just 2. If you have any questions or specific problems other than the kind of overview I've done, there's comments below. I know, don't you love it when YouTube people put that little, there's comments below, down there. Also, if you are interested, I might be putting a lot more of these videos up, so they're in somewhere. way down there. I'm not going to put it in the video itself. It's kind of distracting. Again, thanks so much for watching, and talk to you later.